So hello everybody, welcome to our course today is about the compressors in oil and gas industry. So this part is this presentation and this course is part of the fundamental of machinery equipment diploma. So have many parts, a part about the compressor, part about the pumps, and each type have positive displacement and dynamic. So let's start the compressors, our compressor presentation. So we have in this course, we are going to talk about compressor fundamentals, compressor types and hydraulic coverage map, and compressor application and surfaces. So what are the compressors? Compressors are machines used to increase the total energy of compressible fluid. So compressible fluid, either gas or vapor, that's how it be differentiated from the pumps that handle incompressible fluid. That means the energy, the density of the liquid has not been changed from compressing, from pumping. But in compressors, the gas density has been changed, that's why it's compressible. And this compressible effect that we will discuss, that's will affect the performance of the compressor. If one of any parameters is changing the density, then the hydraulic performance and output of the compressor will be changed. We have two types, like the pumps. We have two types, positive displacement type and dynamic compressor type. The best of positive displacement compression is defined as the increase of pressure of the gas caused by operating in a fixed volume. So one of characteristics of the positive displacement compressor that is deliver fixed volume flow rate regardless the resistance, regardless the changing in inlet condition from the density, molecular weight, compressibility. So it's a fixed volume in confined space. Types include different compressors, like we will say. This concept can be best envisioned by using sample range. As one moves the plunger, the volume inside is displaced, so that is positive displacement. It will be displaced regardless of the resistance in which a compressor operates. This is for sure provided sufficient power is available. If no power available, so as a driver will be overloaded and tripped. The design of compressor can meet the pressure requirement. Reciprocating a rotary, piston, rotary loop, and screw compressor, all different types of positive displacement. Dynamic compressor, the second category, second types, is increasing the pressure of the gas using rotating blades to increase the velocity of the gas. Types include the axial and centrifugal compressors. We will see later. Are two velocities which determine the pulse of these velocities occur at the exit of the moving blade. This is mentioned in Euler equation, if you remember from undergraduate studies of the engineering. So they are the tip speed is this function of the blade tip diameter and RPM, compressor RPM, how at what RPM it's operate. For centrifugal compressor, usually it operates above 5,000 RPM, 8,000, 11,000, so it's high speed. So the RPM, compressor revolution per minute, and blade tip diameter. The second velocity is the relative velocity. What is the relative velocity? The velocity of the gas between the two blades. This is are shaping the performance of the dynamic compressor and shaping the curve. Again, compressor application vary from home refrigerator to large complex petrochemical plants. Compressor can be used for gas transmission through pipelines, storage and transmission of energy, volume reduction for storage and transportation like LPG, liquefied petroleum gases, and LNG, liquefied natural gas. So as you know, the natural gas by itself, it is a rigid supply chain. That's mean when you produce a gas, so you have to move these gases or storage it. And when storage, it is a refrigeration cycle because it's boil off. Process requirements, chemical reaction like DHT, KHT in refineries, energy conversion like heat pumps. So again, we have two types, dynamic one, centrifugal and axial, and the positive displacement that rotary and reciprocating. Reciprocating, the most used one is double acting reciprocating compressor. In rotary, screw compressor have many applications. There is a liquid ring, there is a vane, there is a loop. These are the different types we will go through in this course. So what is the application? For rotary loop, it is conveying powder and polyethylene. For rotary vane, air, it is air blowers. Also used a gas turbine starter. Sometimes in a gas turbine we need to start the gas turbine to minimum speed 40% of operating speed for the combustion, for the compressor to be starting and the combustion is starting. So to reach this speed we use a starter. Starter sometimes is electrical, some pneumatic, some hydraulic. So if it's used as a pneumatic one, so we use air. And rotary screw, plant and instrument air compressor, low flow process of gas recycle, sulfur blowers. And the rotary liquid ring, it is used in crude unit vacuum to create a vacuum and various saturated gas application. And for reciprocating, it's a plant and instrument air of gas, low flow mean. In plant instrument air compressor for low flow application. If the demand, if the users is not too much, like in terms of 700 meter cube per hour, so it is reciprocating one. Okay, maybe recycle like hydrogen makeup compressor or gas reinjection. Also in DHT and KHT units, you have hydrogen makeup and hydrogen recycle compressor. Usually in hydrogen surface due to low molecular weight, so the phototropic head is very high, so you have to use reciprocating instead of centrifugal because you are going to do to install mini centrifugal, and centrifugal compressor is expensive one in the compressors. So next one is centrifugal single stage air blowers or recycle application. Centrifugal single stage integral gear, low flow recycle or off gases. Off gases, instead of make it flaring to direct these gases to the flare, use these gases in separators or like that to compress it and use it as a fuel or many application. Okay, so it's used for low flow, medium to high molecular weight application. Centrifugal multi-stage side load horizontal split or barrel compressor. Horizontal split compressor like propane, polyethylene, ethylene, freon, mixed gases, refrigeration. And the highest application, the highest flow rate and the highest pressure compressor centrifugal is multi-stage barrel type using in different applications. Recycle, reinjection. And there is a centrifugal multi-stage integral gear. This is integral gear compressor with planetary gear, and there are many blades, many impellers rotating. So it is used for plant and instrument air if its amount of air demand is high in the plant. So process application requires proven field experience. And the axial compressor, the most example and most application for the axial compressor is the gas turbine. So the compressor is either dynamic or positive displacement or static. So reciprocating or screw, axial or centrifugal. One of comparisons between the compressors to be sure what the characteristics of the compressors is compression. The compression of positive displacement is on volume. So combined is a volume, so we create the flow on a fixed volume. While in dynamic type or turbo compressors use a dynamic, so you convert the mechanical energy from the shaft to accelerate the flow, so to increase the kinetic energy of the flow, change the momentum. Then you decelerate the flow again to recover this dynamic pressure into the static pressure, which is useful for application. I don't like to have too much flow at high velocities. No, you need a static pressure. That's make energy. From the motion perspective, it is reciprocating in reciprocating type and is rotating for the rotary one screw and rotary vane, liquid loop and liquid ring. And for centrifugal one is rotating. How about delivery? The flow rate delivered. In reciprocating is intermittent. That's mean there is a pulses. So you have to attenuate these pulses in order to obtain a quasi-continuous. You have to install another devices external. In the rotary itself has the property that its flow is quasi-continuous, and for sure for the dynamic type compressors or centrifugal one, the flow is continuous. What is about the flow range? The flow range, it is low for reciprocating in terms of 700 meter cube per hour actual condition, and it's going increasing in screw compressor up to maybe 5,000 meter cube per hour. And after that we will find the centrifugal from integral gear 6,000 meter cube up to maybe 50,000, 100,000 meter cube per hour. And after that you will find the axial compressor that reaches in terms of million meter cube per hour. For the compression ratio, reciprocating is high, the screw is medium, and centrifugal is medium, but for axial, due to its type, as we'll discuss later, it is low. So if you would like a high pressure, for example, the inlet pressure is 1 bar for the axial compressor, and you're asking for 14 bars. So do you think how many stages do you want? Maybe 12 stages, 12 impeller stages in order to achieve this from 1 to 14. While me in centrifugal compressor, maybe 2 or 3 stages is enough. And for reciprocating as well. Okay. So what is the function of the compressor is render specific volume of gas from a given initial condition. So you have to give the supplier, you have to specify the compressor, the inlet condition, complete inlet condition you have to specify. What is the inlet condition? The suction pressure, suction temperature, compressibility, volume flow rate in actual condition. What else? Molecular weight. So you have gas analysis, what's the gas composition, and you have to specify on the other side, in the charge side, what is the requested charge pressure. That's all. All other parameters is the charge and absorbed power, and it will be calculated by the supplier. If you don't like to calculate it, but it's better to know how many stages. So into desired final condition, pressure and temperature. This is simple map represent how reciprocating with respect to the rotary screw. Usually the rotary vane and loop, it is acting as a blower. It's terms of pressure increase in terms of 1 bar or 1000 millibar. But for the screw it can reach 27 bar, 40 bar. Then the turboradial is coming in between, ending by the axial one, which is reaching million. So this comparison, these figures of range of flow and the pressure range we'll discuss after knowing how to operate each type. Let's start.